Alright guys, I'm going to go over 16, 17, 18, those fire starters. Everything is about radicals. Remember, with radicals, it's kind of like simplifying fractions. Remember, we want no decimals. Everything's kind of like you're trying to just, there's two rules. So there's two rules you got to remember. So rule number one, no perfect square factors. In your radical. So inside your check mark symbol, you cannot have a perfect square. That's a number from this list over here. So that's rule number one. The other rule is no radical in the bottom. And it's called the denominator. So that's when we use conjugates. So you always start with rule number one. You look for perfect numbers inside the radical. Remember to, and I call it a jail. So to leave jail, you have to, one, be perfect. And you have to change. That's why it's really important to know these perfect squares. Like I said, it doesn't matter if you don't know them off the top of your head, but there is no quiz. I don't know why. That was from last year. So 49, 36, 289, 400, 256, 121, 144, 4, 16. I'm sorry. 4, 100, 81, 196, 169, 25, 9, 64, 324, 225, 1, 361. Alright, so that's going to help you if you know those. It's not the end of the world if you don't. So we're going to start with this one over here. Right away, I have the square root of 5 over 16. I don't have any fractions on this list here. There's no fractions there. So since there's no fractions, I'm going to take the radical to the top and take the radical to the bottom. 16 is perfect. So since 16 is perfect, he's going to change into 4. Radical 5 just stays the way it is. Radical 5 has no perfect square factors. So we're done. So that's how you know if you have to break down a radical or not. You could break down a radical if there is a perfect square factor or there's a radical in the bottom. This one's done. So you're allowed to have a radical 5 on top. There's no radical in the bottom. You're done. Next one. First thing I'm going to do is I'm going to take the radical to the top and the bottom. So I have radical 18 over radical 11, or square root of 18 over square root of 11. Now I have a couple different things to do. I always personally usually look for perfect square factors. So I usually do this first. So what I would have seen is that 18 is not perfect, but 18 has a perfect factor, 9. You don't have to do this first. There's another way to do this. And actually, I think in class I did it slightly different. So I say 9 times 2 is 18. 9 is the perfect guy. He's going to change. He leaves the jail. He turns into 3. 2, he's going to stay in jail forever. And then we have our radical 11. So this one is done. All right, I did the perfect square factors. Now I have a radical on the bottom. So this is where I have to use conjugates. So anytime you use conjugates, I call it the conjugate box. I'm going to multiply, and I make this a dotted box. Remember, this has to equal 1. Now this is an easy conjugate. And here's how I explain it. Conjugates are special somebodies. They're like soulmates. So radical 11 has a soulmate. It is the perfect one for it that will make the radical go away. There is only one number that you can put in this bottom right here. There's only one number that goes right there that will make radical 11 and the radical disappear. So with easy conjugates, with radicals, you take the radical and you just write the same exact thing. Now the only way to make the top and bottom, the only way to make this box equal to 1 is if I take this radical and I copy and paste it right there. You have to do that. Alright? So, easy conjugates, the box equals 1. That means the top and bottom match exactly. So now I just multiply across the top. So I do 2 and 11, they are both in jail. So I have 3. Then I have the square root. 2 and 11 are in jail, that's 22. All over the square root of 121. So that's because 11 times 11 is 121. Now look, 121 is perfect. Right here. So he's going to change. So your final answer becomes 3 square root of 22 all over 11. You do have to make sure that 22 can't be divided by a number on this list, and it cannot. So that's it for that one. Next one, there's a bunch of different ways to do this. What I think the easiest way to do this next one is I say 5 and 3, those guys are out of jail, so that is 15. 24 and 10, those guys are in jail, so it's square root of 240. So guys who are out of jail can be multiplied with guys who are out of jail. Guys who are in jail, 24 and 10, they can be multiplied together because they're both in jail. Now I look at 240. 240 is not on my list. So I have to find a number on my list that goes into 240. Now remember, I start at the top of my list, so I'm going to start at 225, really 190. I know none of those are going to work. I really know, I just divided by 2, and I know like anything under 120 is not going to work. But you can check it. You go 240 divided by 196, decimal. 240 divided by 169, decimal. 240 divided by 144, decimal. 240 divided by 121, decimal. 240 divided by 100, decimal. I keep on going until I don't. So I'm just checking all these numbers until I do not get a decimal. So I do 240 divided by, let's try 36. Doesn't work. 240 divided by 16, 15. So 25 didn't work, and then 240. So I have 240 is 16 and 15. 16 is perfect. So 16 gets to leave jail. He multiplies. So this green 16 turns into this blue 4. And this 15 stays in jail forever. 15 times 4 is 60, so I end up with 60 square roots of 15. You always do double check and make sure there's not a number on this list that goes into 15, and there's not. That's just to make sure you didn't mess up and have to do it a second time. So that's it. Alright, 17. The exact same concept, almost. I just changed some of the numbers. So 36, 25, 400, 361, 225, 100, 121, 9, 1, 81, 64, 169, 144, 16, 4, 49, 289, 196, 256, 361. I'm sorry, 324. Now look, there's no fractions on my list here, so I'm going to take the radical to the top and the bottom. Remember, 36 is perfect. He's going to leave jail. He turns into 6. Radical 7, he's stuck in jail forever. He's a murderer. Done. I take the radical to the top and the bottom in the next one. So I say radical 11 over radical 7. Remember, there is a radical on the bottom, so I have to use conjugates. So this is where the conjugate box comes into play. Remember, I multiply. So this is, I need to have easy conjugates here. So I take radical 7, I just write it again because that's what it says right here. Take the radical, make it the same. Now the only way for this box to equal 1 is if I take the radical 7 that's on the bottom and I copy and paste. Remember, the top and bottom must be the same in our conjugate box. So I multiply radical 11 times radical 7, I end up with radical 77. On the bottom, and I usually don't show this step, but 7 times 7 is 49. Remember, 49 is perfect. So I end up with radical 77 over 7. And you're done. Remember, 7 cannot divide by the radical 77 because 7 is out of jail and 77 is in jail. They cannot mix and match. 77 is done because there's not a number on this list that goes into 77. So we're done. That's it. The third one, remember, 6 and 8 are both out of jail, so I have 48. Now I'm going to do 12 times 8 because they're both in jail, or 12 times 18, I'm sorry, and I get 216. So I do 12 times 18, I end up with 216. So once again, 216 is on my list. I start dividing. I end up with 216 is 64 times 3. That's not right at all. Let's see. 216 divided by, I lied to you there. Thought 36 and 6. I went nuts for a second. So I just started. It's not 64. It's 36. I don't know what I was thinking. 216 is 36 times 6. Remember, 6 is the perfect one, so 6 gets to leave jail. So I have the green 48. 36 turns into this purple 6. And this blue 6 stays in jail forever. So I finish with 48 times 6. So I end up with 288 square roots of 6. That's it. Alright, 18, the exact same concept again. 25, 16, 361, 324, 196, 81, 100, 4, 400, 64, 49, 144, 121, 9, 1, 36, 256, 169, 225, 289. I don't think I made any mistakes, but I was doing really quick, so double check my math there. Remember, that's to help you understand this list a little bit better, be much easier to identify radicals. Take the radical at top and bottom on the first one. 169 is perfect. He turns into 13. 8 can be broken down, so we're not done here because 8 is not perfect, but 4 goes into 8 2 times. So this purple 4 turns into this purple 2. The purple 2 is the blue 2. Boom. That's it. So I had to simplify the top first. Remember, you always have to look for a perfect square factor. That's always look for a factor on this list. Next one, radical 13 over 5. I'm going to split it to radical 13 over radical 5. 13 cannot be broken down. 5 cannot be broken down. The only reason we have to do any work here is because there's no radical on the bottom. That means I have to use conjugates. This is an easy conjugate. So when I make my box, remember, here's the conjugate box. I always make it a dotted box. Remember, that's your human brain step. I want to see this step. You're going to tell me it's equal to 1. That's you to remind you that it has to be equal to 1. So I just take, look, this tells me that if I have a radical, I just copy and paste the same radical. And to make it the same on top, I make it the same on top. Now both these guys are in jail, so 13 and 5 are both in jail. So I do 13 times 5 to get 65, I believe. Yep, that's true. So I have the square root of 65. And usually I just know right away 5 times 5 is 25. The radicals cancel out. So that's me skipping that step that I usually write, that I've been writing for you. So I know that the radicals, I know that if I have radical 5 times radical 5, the radical just disappears and cancels out. So that's it for that one. Next one, I'm going to have 3 times 7, which is 21. Now I'm going to have 18 times 24. So I do 18 times. There are other ways to do this one that some people might think are faster, which is fine. 18 times 24 is 432. So now I just start guessing. Now if you're not sure, you double check and make sure 432 is not perfect. It's not. I get a decimal. I'm just going through my list. I'm trying to find something that goes into 432. So I'm just going through the list. I'm just starting here, and I'm just going through this list and dividing in my calculator. So I do 432 divided by all those numbers. And I get 432 divided by 144 is 3. So this is 144 and 3. So I have the 21. Now, 144 gets to leave jail, but he turns into 12. Remember, he's got to change. He's perfect, but he changes. 3 stays in jail forever. So to finish it, I do 21 times 12, 252. That's it. The keyword is thermometer. The keyword is thermometer.